All right, so this lesson has a lot of great information and the last part of your statistics. So it is the fundamental counting principle. Don't write any of this yet, just listen. The first problem says the deli has 5 bread types, 5 meat types, and 4 cheese types. How many different sandwiches can you make? Well, in this case, if I go to my favorite tree diagram, 5 bread types. Out of those 5, each of those get 5 meats. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I would do that to each branch. And then from there, after I did that, then you would say, okay, you have 5 bread types, 5 meat types. Now what you're going to do is you're going to have 4 cheese types. So each of those, 1, 2, 3, 4 cheese types. You guys can see that my diagram's super ugly. Okay, so we don't like that. So how many options can you make? This is a fundamental counting principle that says, well, if you have, now you can write this down. Bread, meat, and cheese. You have 5 options for bread, 5 options for meat, 4 options for cheese. Multiply those. 5 times 5 is 25, times 4 is 100. This will tell you how many different sandwiches you can make. It doesn't tell you the kinds of sandwiches, but it tells you how many different. And so that's the fundamental counting principle. You can take your options and just multiply it. And you don't have to do a ugly tree diagram. The next one says a password is 2 digits using numbers 0 to 9 followed by 2 letters. How many different, let's say, passwords are possible if digits and letters can be repeated? So same thing. This has a password with 2 digits followed by 2 letters. You can go ahead and write that down. How many numbers are there between 0 and 9? Careful, that's a trick question. Between 0 and 9, well, here's 1 through 9 is 9 digits. If you add the 0, there's actually 10 different numbers. So you have 10 options for that first number. Let's just say I used a 5. I could still use a 5 again because you are allowed to repeat. So that's 10. How many letters in the alphabet? 26. And that's all multiplication. So you're just going to write it, multiply it through, plug it into your calculator. Same problem. This one says how many different passwords are possible if digits and letters cannot be repeated? Same problem, except now number, number, letter, letter. 10 options for the first one. If you use like a number 3, you can't repeat the 3. So now you only have 9 options. Letters, 26 letters for the first choice. After you've used a letter, you can't reuse that letter. So now you have 25 choices. And again, just multiply all of that. Number 3 says, you're having trouble remembering the password for your email account. It is 4 characters long. The first and last characters are letters of the alphabet, and the remaining 2 digits must be chosen from 0 to 9. How many different passwords are possible if digits and letters can be repeated? Okay, let's see. So let me read that again. It says it's 4 characters long. You can write this down. The first and last characters are letters of the alphabet. And the remaining 2 digits must be chosen from numbers 0 to 9. How many different passwords are possible if digits and letters can be repeated? Well, if you have 26 choices here, you still have 26 choices here. How many numbers? 10, 10. This is actually the same problem as this, only they put it in a different order. So same. Part B says how many different passwords are possible if digits and letters cannot be repeated? Well, so now you're going to have 26 choices for the first one, 25 for the other letter because you've already used one, 10 choices for the first number, and then 9 choices for the second number because you've already used one. And again, they're the same problem, just asked differently. Okay, number 4. Number 4 says the last page of your test There we go. The last page of your test is going to have 6 multiple choice questions. Coelho wants to make different versions. I used to teach this with Coelho, that's why I said it. But so Ms. Gandolfo and I want to make 6 different versions by arranging the problems in a different order. How many possible arrangements could I make? So let's just say I have 6 questions. If I took this question and swapped it out here, now I have a new test. If I switch these 2 questions, now I have a new test. And actually when we make tests, we actually switch questions and switch answers. And that actually kind of gives you a new problem. All right. And so you guys can see I can keep switching numbers and coming up with new orders. Anyways, how many ways could I do that? Well, there are 6 questions. So 1, 2, 3, 4, 5, 6. 6 choices for the first question, 5 choices for the second one, 4 choices, 3, 2, 1. And I've used all the things. So this is 6 times 5 times 4 times 3 times 2 times 1. Plug that into my calculator and I get 720. Now, there is actually something new that's called a factorial. A factorial is an exclamation point on your calculator. If you have the nice one, you're going to try to find it. So let me just show you. 6 times 5 times 4 times 3 times 2 times 1. We already know the answer is 720. Well, mathematician says, wait, I don't want to have to multiply this out all the time and keep rewriting it. Well, isn't there a faster way? Or let's come up with, like, if I had to do 20 factorial, I don't want to multiply that out. So they have a factorial that does that for you. And you just have to find it on your calculator. It's an upside down exclamation. Oh, and that was supposed to be a 6. So 6 factorial is 720. On your cell phone, if you don't have the calculator, it does do factorials, and so that's good to know. Let's find it on your cell phone. Go ahead and grab your cell phone. And let's see if this shows up clear. Okay. So you're looking for a factorial button, and my phone's a little bit blurry, so it's kind of hard to see, but did you guys find it already? Okay, the factorial button is going to be right there. Okay, and it looks like x factorial. So if I wanted to find 6 factorial, I go 6 factorial, 720. Okay, and that's how you do it on your calculator. So again, it is 6 factorial. Nice. Okay. The next problem says, how many ways can 5 different books be arranged on a shelf? Well, same thing. If you have 1, 2, 3, 4, 5 options for the first one, 4, 3, 2, 1, you can plug that into your calculator. That is the same thing as 5 factorial, which is 120. Suppose you didn't have a calculator and you actually had to multiply this out. You can always multiply how your teachers taught you. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1, 120. Done. Or you can actually multiply in chunks. And if I know, oh, 5 times 2 is 10, okay. 4 times 3 is 12. Well, 12 times 10 is 120. 120 times 1. So as long as you multiply them in any order, it's fine. That's the same thing as addition. Addition and multiplication, you can add and multiply in any order. That is not true for subtraction or for division. Okay. Next problem says, there are 7 people competing in a race. How many ways can the racers finish the race? Well, you have 1, 2, 3, 4, 5, 6, 7 spots. You have a first place spot, second place, third, fourth, fifth, sixth, and seventh. If there's 7 racers, then you have 7 choices for that first spot. Somebody won. Now you only have 6 choices for second place. Somebody got it. Now you only have 5 choices for third place. Okay, you've gotten 3 people in. Now you only have 4 choices for fourth place, and so forth. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Same thing as 7 factorial. And plug that into your calculator. Next question says, how many different ways can 3 of the racers finish first, second, and third? So you still have how many people in the race? 7. And they go, I don't care about everybody. I only want first, second, and third place. Well, how many choices do you have for first place? 7. Somebody came in first. How many people now? 6. Somebody's come in first and second, and so you only have 5 choices and you don't care about the rest. No, we do. Okay. Go ahead, write that down. Plug that into your calculator. 7 times 6 times 5, 210. There is a new rule. A new rule is a permutation. So write this down. 210, that's your answer, 7 times 6 times 5. And again, mathematician says, well, let's see. They came up with another way of writing this. This is 7 permutating 3. And I'll talk about what that means in a minute. Most of you, if you don't have the calculator, you can't actually do this this way. You would have to use a formula, and I'll show you the formula in a minute. If you do have your calculator, it's probably under like menu probability. So mine is under probability, and it's this one. So I would have 7 permutating 3, 210, a little bit faster. So that's if you have it. I don't believe that your cell phones do it, but your cell phones could do the formula that way. Before I go into the formula, let me explain a permutation a little bit more. All right, let's say I had, and it's all right here. Okay, permutation, order matters. That sounds simple. What does that mean? Let's say we had, and don't write this down, but let's just say we had the letters in the word cat. How many different ways could I arrange the letters in the word cat? Well, I could do cat. I could flip those to CTA, ATC, ACT, TAC, TCA, and so forth. And you got it, right? So there's 6 different ways. Okay, now let's just say I had another 3-letter word, mom. How many different ways could I arrange the letters in the word mom? What if I switch this M with this M, or these 2 M's? Doesn't matter, right? This one order matters because the letters are different. This one order doesn't matter because it's the same thing. So when order matters, your number is actually, you're going to have more options. Okay, let me do one more example. Suppose I have Cassie, Lulu, and Canyon, and they're running for office. Cassie's president, Lulu's vice president, and Canyon is treasurer. Yay. Okay, good group, right? Now, if I were to, how many ways can these 3 people hold office? They're still going to be president, vice president, and treasurer. Is that different than maybe Lulu is president now, and Cassie's vice president, and Canyon is treasurer? Right. Lulu would make an excellent president, okay? And so they're still the same 3 people, but they're holding office in a different way. Well, now let's switch it. Let's make Cassie treasurer, Lulu's still president, and now Canyon is vice president. Again, how many different ways? This is going to be like the cat one. There's 6 different ways that these 3 people hold office. Why? Even though they're holding the same positions, order matters. Cassie being president is different than Lulu being president, which is different than Canyon being president. Okay, so order matters. And that's when you would use a permutation. So that's the idea behind permutations. Formula. Formula says, well, if you have your calculator, you just plug it in, and it's nice and simple. If you don't have your calculator, they go, well, actually, you can still solve it. You'll use this formula. It says N permutating R. and it's always the bigger number here, the number of items, and you're permutating, you know, however many, is equal to n factorial divided by n minus r in parentheses factorial. All right, so let's just do this first one. It is, and write it kind of small. All right, so here I have my formula. 9 factorial divided by the quantity 9 minus 4 factorial. 9 factorial, I'm just going to go ahead and write it all out. As you guys get better with this, you'll know what numbers to write out and what numbers not to. So 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 9 minus 4 is 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. Cancel, so all of these cancel, and you're just left with 9 times 8 times 7 times 6, 3,024. All right, go ahead, try to do this one, 8 factorial. And also C. You guys can just watch the video, check your math. And what's your answer for this one? 1. Okay. All right. And that makes sense. And you could have just said, oh, it's 8 factorial divided by 8 factorial. Those cancel and it's 1. Oh, a side note. I have to tell you the definition of what 0 factorial is. So write this down in case you need it at some point on your notes. Can you see that? Okay, 0 factorial is actually equal to 1. And what they're saying, it's dark, huh? Okay. So 0 factorial is actually equal to 1. Let's make that another rule. What they're saying is, if you have 0 things, how many ways can you arrange 0 items? 1 way, I guess. Okay, try to do this next one. 7 permutating 7. So this is 7 factorial. Zero factorial is actually just 1, we just found out. So this is actually just 7 factorial. And it is 5,040. 7 permutating 7 is actually, let me see that, is this problem right here. How many ways can 7 of these things be arranged? So this is 7 permutating 7. So 7 factorial is actually the same as 7 permutating 7. Okay, so there's 3 different ways to do this one. 7 factorial, 7 permutating 7. Most of the time I just think about it this way. Okay, all right. So this next problem says you're considering 10 different colleges. Before you decide to apply to college, you want to visit some or all of them. And how many orders can you visit? So this is saying like, oh, if you want to visit, you know, UCSB and Cal Poly, it's actually different than if you were to go to Cal Poly first and then visit UCSB. So does order really matter? Maybe, maybe not. I don't know. So they're saying that it does. Okay, so if order matters, we're thinking permutations. So let's do this one. How many ways can you visit 6 of the colleges? So it's 10 permutating 6. If you didn't think about it that way, you're trying to visit 6 colleges. 1, 2, 3, 4, 5, 6. 10 to choose from. 9, 8, 7, 6, 5. Okay, these are the same problems. Plug it into your calculator and whatever that is. That's a 5. How many ways can you visit all 10 colleges? Ten permutating 10. Or that's the same thing as 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's the same thing as 10 factorial. Either way, plug that into your calculator. This is a 6. So you guys can see that these numbers get really big. Next one, this one's a good one. There are 9 players on a baseball team. How many ways can you choose the batting order for all 9 of the players? So part A and then part B. Does order matter when the players are up to bat? No, yes, no. I think they actually do put them in a specific order. So we're going to say order does matter. So this is going to be 9 permutating 9. Same thing as 9 factorial, or same thing as 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, all of these things are the same. It's just however you think about it. And honestly, doing this part is actually pretty easy, just to be like, oh, there's 9, 8, 7, like 9 options. Oh, that's 9 factorial. So B. B says, how many ways can you choose a pitcher, catcher, and a shortstop from the 9 players? Okay, so there is a pitcher, catcher, and a shortstop. That is 9 options here, 8 options here, 7 options here. So that's kind of how I think about it. It's also the same thing as 9 permutating 3 because order matters. And this is not a factorial because it doesn't take everyone in that group. A factorial always takes everyone in that group. We only care about the 3 positions, pitcher, catcher, and shortstop. So it's 9 permutating 3. This next one's interesting. Find the number of distinguishable permutations of the letter in the word. So if we had done cat, this is actually 3 factorial. So 3, 2, 1. So 3 times 2 is 6. Okay. Texas, same thing. 1, 2, 3, 4, 5. So that's going to be 5 factorial. Plug that into your calculator. Okay. Letter. 1, 2, 3, 4, 5, 6. Well, we know it would be 6 factorial, but there's one problem. Oh, you can't see that. Sorry. Okay. Got Texas? 5 factorial, 5 different letters. Okay. 6 factorial is not correct for the word letter. Why? There is a repeat. There are 2 T's and 2 E's. We have to divide out our repeats. So we're going to divide by 2 factorial and then divide by 2 factorial. If there had been 3 t's, you would divide by 3 factorial. If there had been 4 t's, you would divide by 4 factorial. And you cannot combine these. You can't multiply, oh, it's just 2 plus 2 factorial or 2 times 2. No, you have to do 2 factorial and then a 2 factorial. So I'm going to work this one out. 6, 5, 4, 2, 1. 2 factorial is the same thing as 2 times 1, 2 times 1. So I can either cross this off with the 2 right here, but 2 times 2 is 4, so I'm always going to try to reduce the bigger number. I could have also gone 2 into 6 is 3 to make that number smaller. I'll just cancel out the 4. So, but it doesn't really matter how you reduce. Okay. 2 cancels with the 4 twice. This 2 cancels with that. 1, 1, 1. So you're left with 6 times 5 times 3 times 2. Okay, bookkeeper. Oh, that's a good one. Okay, let's count the letters. Count them twice. Okay, 10 factorial. There are 10 letters, but we have to divide out the repeats. Let's see, there are 2 O's. There are 2 K's. And there are 3 E's. All right, expand it, cancel it out, or just plug it all into your calculator. Maybe we should practice plugging it into your calculator. Let's see. If you did this one on your calculator or on your cell phone, I would probably do all of the denominator first. And so it's better just to do it all in pieces and write it down on your paper. But I would go 2 factorial times 2 factorial equals times, and I always do the equals afterwards, 3 factorial equals 24. So that's going to be 10 factorial divided by, so then I'm going to go 10 factorial divided by 24. Okay. All right. So just make sure that you do know how to work it out the long way. All right. The next one, this one is combination. So these permutations, you can actually use the formula. You can think about it. Doesn't really matter. Combinations. If you're doing combinations, use the formula. This one you really have to, because this one actually divides out your repeats and you wouldn't normally see that. So in a combination, it is n choose r. So this is n factorial divided by, here they put a k, but that could be like r factorial and minus k factorial. So it's the same thing as a permutation, except they added this extra number right here. Why? Because you're dividing out your repeats. So in this case, remember, this would be a permutation, combination. You have that extra variable that you're going to divide out your repeats. When would you use combinations? So permutations you'd use, oh, when you're president, vice president, secretary. Order matters. Combinations is, oh, just a group. How many ways can you arrange, let me find them. How many ways can these 3 people form a committee, a group? And so those are your key words. That means combinations. Let me find the, okay. If I have Cassie, Lulu, and Canyon, how many committees can I make with the 3 of them? If I'm making a committee of 3, a group of 3, how many ways can I put them in a group? 1 way, okay? So this is a combination. Combination is when order doesn't matter, okay? It doesn't matter who's sitting where if they're just in a group. So question 11 says, how many ways can you make groups of 3 students? So combinations, if they use the word committee, can't spell it, a group, if they use the word combinations, okay? So how many ways can you make a group of 3 students out of 15. So this is 15, and they call this choose. So 15 choose 3. 15 choose 3. I'm going to use my calculator. And so I got the probability, so it's 15 choose 3. And I got 455. Okay, so I know the answer is 455. Should I actually work this out? We'll work out the other ones. Okay. Let's just say now that you don't have a calculator. Okay, we're going to go to the formula. Formula says this is 8 factorial, and write kind of small, divided by 2 factorial, 8 minus 2 factorial. So this is, now pay attention to this part. I know that this right here, 8 minus 2, is going to reduce to 6 factorial. Okay? Because I know that this is going to reduce to 6 factorial, when I expand this, I'm going to go 8, 7, 6. I could write 6, 5, 4, 3, 2, 1 all the way down, but I'm going to say, wait. Look, this is going to be 6 factorial here. I'm going to do 2 times 1, and this is 6 factorial. I'm not going to write it all down because I know they already cancel. If you choose to write it all down, it still works. Okay. Or you can see in this one, I stopped here, 6 factorial, or I wrote this one down, but here I said, oh, I don't want to rewrite it, and I just canceled that. So now I'm going to go ahead and cancel. 6 factorial, 6 factorial, 2 reduces with the 8, so that's 4. Oh, 4 times 7, easy. 28. Again, if you have the calculator, calculator is going to be great because you could just type it in exactly 8 choose 2 and get your answer. But if you don't have the calculator, then you're doing it longhand. Okay. Next one, 10 choose 4. Go ahead, work that out on your own. Tell me what the answer is. Okay, so I wrote it out and I can see the 6 factorials cancel. Let's see, 4 and 2 cancel with the 8, and then the 3 reduces with the 9. So I have 10 times 3 times 7. 7 times 3 is 21. 21 times 10 is 210. Not too bad. All right, we still have one more problem to do, but just real quickly, so you know fundamental counting principle. Fundamental counting principle says how many ways can you arrange everything? Take your options and multiply them through. Then you have permutations. Permutation says, oh wait, order matters. You can think about it. You can use factorials, or you can use the formula. All of these are the same way, okay? Not a problem. The other one you guys learned is combinations. Combinations, you cannot think about it. You have to use a formula because it accounts for you dividing out your repeats, okay? And then our last problem. This is a tree diagram and kind of like this problem. Here we go. take a minute, read it to yourself, try to set it up before I get started. All right, so a teacher has two boxes, type A batteries, type B batteries. 60% are type A, 40% are type B. The probability that a type A calculator is faulty is 1/10, and the probability that a type B calculator is faulty, okay, so we have to write that in. Type B is faulty. All right, so we have all the information in our diagram, and then we just have to make sure every tree branch always has to add up to 100%, or 1 in this case because they used it as decimals. So this is going to be a 0.9, and this is going to be perfect. Okay, now I can actually find all of these, type A faulty, type A not faulty, multiply these two and get out those probabilities, and that also would add up to 100. But let me just go to the answer or the question and see what they're asking. It says, find the probability that a calculator is a faulty type A. So a faulty type A is going to be type A and faulty. So type A and faulty is 0.6. So it is probability that the calculator is a faulty type A is just 6%. The next question is a really good question. It says, what's the probability that your calculator is not faulty? Well, you could have a type A calculator that's not faulty, or you could have a type B calculator that's not faulty. So what you have to do for this one is you have to add these two, which is weird because usually you multiply it. Well, you do have to multiply this part. Probability that it's not faulty here is 0.6 times 0.9. Probability that it's not faulty with type B is 0.4 times 0.88. Probability that it's not faulty at all is going to be this number plus this number. And this is a common question that students miss because they go, oh, it's just, not faulty. No, it could be not faulty type A and not faulty type B, and then you have to add those two probabilities. And most of the time we always say, oh, you multiply when you get your answer. But in this case, you do multiply to get that probability. You multiply here to get this probability, but then you add these two. And so you're almost 90% likely not to get a faulty calculator. All right, and that's it for today's lesson.